Today we are taking with S block elements. Today we are dealing with S block elements. Then S block elements, which includes 1A as well as 2A group elements. 1A group elements are also called alkali metals. 2A group elements are also called alkaline earth metals. So therefore in 1A group, uh, hydrogen position is an exceptional because hydrogen chapter separately includes. Other than hydrogen, from lithium, sodium, potassium, rubidium, cesium, and francium, they are included as 1A group elements. They are called alkali metals. Alkali means soluble base. And 2A group elements are also called alkaline earth metals. And those elements are beryllium, magnesium, calcium, strontium, barium, and radium. So therefore, and 1A and 2A, they included as S block elements. So therefore, 1A group elements, then their uh, occurrence when we refer, lithium occurs as spodumene, that is LiAlSiO3 twice, and petalite LiAlSi2O5 twice. Then those two ores occurs on the Earth's crust, and sodium occurs as rock salt NaCl, then soda ash Na2CO3, then washing soda Na2CO3 10H2O, and global salt Na2SO4 10H2O. Then those are the various ores available. Chile saltpeter has NaNO3, and these similar types of ores available. Potassium occurs as sylvine, that is KNO3. Then Bengal saltpeter KNO3. Then in such a way, carnallite KCl MgCl to 6H2O, and other occurrence is very much lesser. Then occurrence in the periodic table, in such a way, 2A group elements also occurs on the Earth's crust with a decreasing order. Oxygen is the most abundant element, then followed by silicon, then third position occupied with aluminium, fourth position occupied with iron, fifth position occupied with calcium, then sodium, magnesium, potassium, titanium, and hydrogen. The first 10 elements occurrence we would observe. Therefore, calcium occupied with fifth position, magnesium occupied with sixth position in alkali and alkaline earth metals. Sixth and eighth position occupied with sodium as well as potassium. Other elements are occurred in traces amounts. Then that is about occurrence of these elements. Then in such a way, other elements like beryllium and magnesium, calcium, strontium, and that is calcium and strontium most widely occur on the Earth's crust. And their general properties, when we come across atomic and ionic radii, when we refer. So, atomic radii, as moving down the group, atomic radii increases 1A and 2A group elements. Atomic radii and ionic radii gradually increases as moving down the group due to shielding effect increases. And then in such a way, across the period, when we take, that is 1A to 2A, when we take atomic as well as ionic radii gradually decreases due to increase in nuclear charge. Due to increase in nuclear charge, atomic as well as ionic radii gradually decreases due to increase in nuclear charge. Then, in such a way, when we come across to these elements, ionization and enthalpy, then ionic means lithium atomic radii is larger than Li plus. Then whenever atomic radii increases, then ionization potentials decreases. So therefore, as moving down the group, either in 1A or 2A group elements, ionic radii or atomic radii increases. Therefore, their ionization energies are gradually decreases. Density, when we take density, also density is inversely proportional to size of element. Therefore, but in case of potassium as well as calcium, densities are lesser when compared to sodium and magnesium due to vacant d orbitals, vacant penultimate d orbitals, then potassium as well as calcium densities are lesser compared to sodium as well as magnesium due to anomalous increment in volume of these elements. But remaining all elements densities gradually increases as moving down the group. Then lattice energy and hydration energy when we take. Lattice energy always, we would observe with increasing of charge or smaller size elements, lattice energies are very high. Hydration energy also, small size we shows higher hydration energy, larger size show lesser hydration energy. Hydration do you mean ions surrounded with water molecules? So therefore, lithium ion Li plus hydration energy is highest in the say 1A group elements. Beryllium ion hydration energy also highest in 2A group elements. Compared to lithium and beryllium, beryllium hydration energy is more than lithium ion due to increase in charge or decrease in size of beryllium ion. So therefore, that we could observe in these elements. So then lithium combines with hydrogen or metals combine with hydrogen and they converted into metal hydrides. Lithium changes to lithium hydride, beryllium changes to beryllium hydride. Lithium and beryllium shows covalent nature and remaining all these compounds show ionic nature. Then suppose when we take cuts with a knife, as moving down the groove, then alkali or alkaline earth metals softness increases and then easily we can cut with a knife. Francium, cesium and francium are liquid metals. Then those we would observe as moving down the groove, then softness of these metals increases. Then when we take other properties, hydration, lithium fluoride as well as cesium iodides are insoluble in water. Lithium fluoride insoluble in water due to higher lattice energy, and cesium iodide insoluble in water due to the lowest hydration energy. With increasing of size, lowest hydration energy or highest lattice energy shows insoluble in water. So then that is we would observe as another property. Then in such a way, suppose when we take compounds of sodium, sodium generally by Solvay process we can prepare sodium carbonate, Na2CO3 10H2O is called washing soda. Therefore, we can prepare washing soda by Solvay. So ammonium soda Solvay process. Then important byproduct we would get as calcium chloride. It is a desiccant or dehydrating agent. In the same way, magnesium when we take it gives magnesium oxide plus magnesium chloride mixture is called sorrel cement or floor cement or joints filling cement we would observe that we can identify like that. Sodium compounds when we take sodium carbonate, that is Na2CO3 is called soda ash. Na2CO3 10H2O is called washing soda. And then in such a way, we can identify magnesium. Magnesium can form magnesium chloride or conlite occurs as KCl, MgCl to 6H2. And other components when we take this potassium, potassium gives KCl or pearl ash as K2CO3. Then those are the compounds we would observe by this flame coloration when we take. Lithium gives crimson red flame color, sodium golden yellow, potassium gives pink violet or lilac flame, rubidium gives red, and cesium shows that is sky blue color. Then in such a way, beryllium and magnesium cannot give any flame color due to high ionization enthalpy. Calcium shows brick red, strontium red color, barium shows apple green, radium and francium are radioactive elements with very small half-life periods. Then when we take these elements or general properties, we would observe with respect to 1A and 2A group elements, some more compounds. When we take calcium shows plaster of Paris as CaSO4 of H2O for making of statues and pieces of chalks. It is most widely used. Calcium occurs in the form of gypsum as CaSO4 to H2O. Then like that, various properties of these group elements we would observe. That is about general idea on S block elements. Let me would come back to objective type on S block elements. Please open your Wiley book, S block elements. Everyone please open your Wiley book. Then in that, come back to level 1 questions. Are you opening, everyone? Okay, level 1 questions. Now, question 1, when we take, that is the principal products, that is important products obtained on heating iodine with concentrated caustic soda solution. So therefore, that is first question, iodine with caustic soda. That is hot and concentrated caustic soda. Do you mean sodium hydroxide? Hot and concentrated, 3 moles of iodine reacts with 6 moles of sodium hydroxide. 5 moles of sodium iodide plus sodium iodate, NaIO3 plus 3H2O we would get. Therefore, important products we would get sodium iodide and sodium iodate. That is option B is correct for question number 1. Then, which has minimum hydration enthalpy? Hydration enthalpy, as moving down the group, gradually decreases. 1A group elements hydration energy is lesser than 2A group elements. Therefore, potassium with the maximum atomic size, hydration energy is inversely proportional to size. Therefore, minimum we could observe potassium, that is option A. That is, hydration energy is inversely proportional to size. Please make it as an important point. Then third question, on heating sodium metal in a current of dry ammonia gas, the compound formed is. That is third question when we come across. Sodium reacts with ammonia, X plus Y moles we would take. Always sodium undergo oxidation with the absorption of ammonia. X moles are accompanied with sodium and the released electron accompanied with Y moles of ammonia. So therefore, here we can identify the formation of this complex. These electrons are called solvated electrons, and this sodium has been converted into sodamide and the hydrogen gas eliminates. Therefore, corresponding moles of sodamide and hydrogen gas releases from X moles of ammonia if it is accompanied with sodium ion. So therefore, there we can identify option C is correct, that is sodamide. NaNH2 is called sodamides. Then next, fourth question when we come across. Washing soda, that is the formula Na2CO3 10H2O. Fourth, B option is correct. Fifth one, which of the following, when introduced into the Bunsen flame, gives pink violet or lilac flame? Lilac flame given by potassium salts, A plus ion, or potassium salts give lilac flame. Question number 6, when a substance A reacts with water, it produces a bubble gas. So substance A reacts with A, then that has been producing gas, bubble gas B we are observing. Therefore, sodium reacts with water. That is question number 6. Sodium reacts with water and it is converted into sodium hydroxide plus hydrogen gas we would get. That is sodium metal. It reacts with water, cold water itself. It always, sodium is lighter than water. It always floats on water with bubbling with the golden yellow flame. and hydrogen gas releases. Then it produces bubbling gas B and a solution of substance C. Solution of substance C, that is sodium hydroxide. Then this sodium hydroxide, another substance D reacts with solution C, it produces the same gas B. So therefore, sodium hydroxide, that is C, reacts with another metal. Let me would take it as zinc. Then sodium zincate plus hydrogen gas releases. Again, B we are getting. Therefore, another substance D, that is zinc metal, it reacts and then corresponding compound produced. And also they continued B. Then with dilute sulfuric acid at room temperature, dilute sulfuric acid reacts with D and it has been converted into zinc sulfate plus hydrogen gas releases. Then this has been showing the compounds A, B, C, D are B answer is correct. That is sodium, hydrogen, sodium hydroxide and zinc. Those four components we would observe in option B. So therefore, sixth question, option B is correct answer. Then question number 7. Which of the following alkali metal emits light of longest wavelength in the flame? Sodium gives golden yellow, lithium gives crimson red, potassium gives pale violet, uh, then cesium gives sky blue violet. Sky blue or violet color we would assume. Therefore, here they are asking longest wavelength in the flame test. Instead of longest, it should be there. Longest wavelength means sharpest amount or least amount of energy. Then violet contains highest amount of energy, and golden yellow, crimson red, and violet. With GR, when we take highest energy, we would observe for violet, and crimson red we would observe the lowest energy or highest wavelength. Instead of giving longest, sharpest wavelength means potassium we have to get. That is given answer in the given options. Because of that is pale violet or else lilac flame. Violet shows always sharpest wavelength or else we would observe longest where that is longest sharpest wavelength or highest energy, but crimson red is more preferred to potassium because of that is violet color shows sharpest wavelength in VGR. Then therefore option we have to go according to that. B answer is correct but not C. Then baking soda. Baking soda means sodium bicarbonate is also called baking soda. Then mark the false statement. The electropositive character, as moving down the group in any group, electropositive character increases. But alkali metals decreases they gave, that is only the false statement we would observe. Remaining all statements are correct. Then 10th question. Which one of the following will react most vigorously with water? Then alkali metals are most vigorous or more reactivity we would observe compared to other group. Vanadium, titanium and calcium. Then rubidium is the most reactive. 10th D answer is correct. 11th one. When sodium metal is dissolved in liquid ammonia, a blue solution is formed. The blue color is due to blue color solvated electrons. They give paramagnetic character and also electron transition take place with blue color. Therefore, there we can identify then blue color. Which one? That is blue color. That is then there we can identify solvated electrons is the correct answer. That is 11th B. Then Chile saltpeter NaNO3, Indian saltpeter or Bengal saltpeter is KNO3. But here we need Chile saltpeter A answer. Then commonly used laboratory desiccant, generally calcium chloride is the common desiccant. It cannot change its physical state, and they are dehydrating or what do you say, hygroscopic substance is calcium chloride, commonly used desiccant we would observe in various drying nature purpose. Then the wire of flash bulb is made up of, then flash bulbs always made with magnesium metal, that is A answer. Na2CO3 10H2O is prepared by Solvay process, ammonia soda Solvay process, that is 15th B answer. 16th one, electrolysis of potassium iodide, potassium hydride produces hydrogen. So then produces hydrogen, we can identify produces hydrogen. So then sodium iodide or potassium iodide, potassium hydride with ionizes to give K plus plus H minus. H minus, anions migrated to anode, cations migrated to cathode. Therefore, 2H minus, it releases H2 by releasing electrons at anode. At anode, which gas produced means what would you give? In the form of hydrate, it produces at anode as hydrogen gas. And therefore, at anode, that is 16th B answer is correct. B option is correct. 17th one, the metal that can be extracted from seawater. Seawater most widely, magnesium metal most widely extracting from seawater. Then the density of calcium is less than that of magnesium because B answer, vacant 3D orbital present in calcium as penultimate shell. Therefore, density decreases due to increase in volume. Due to the presence of 3D empty orbital shows volume increases or density decreases. In such a way, same point we would observe in case of potassium. Potassium density is lesser than sodium, and calcium density also lesser than magnesium due to penultimate vacant 3D orbitals. Then 19. Mixture of MgCl2 and MgO is called sorrel cement, or else joint filling cement, or else floor cement, or tile cement also we can say as sorrel cement. That is MgO plus CaCl2. Its formula we would observe MgCl2 5MgO XH2O we would say. Magnesium hypochlorite, another word, also their chemical name of sorrel cement is also called magnesium hypochlorite. That is the formula we would take floor cement, like that names are included for that sorrel cement. Then 20th, the useful byproduct obtained in Solvay process of manufacture of sodium carbonate. So Solvay process important byproduct is calcium chloride. It is one of the desiccant we can use. 21, that is C answer. 20C. Which one of the following is ionic? Then lithium and beryllium are covalent. Calcium carbon tetrachloride also covalent. Therefore, sodium chloride only one compound, that is ionic compound. 22. On dissolving moderate amount of sodium metal in liquid ammonia at low temperature, which one of the following does not occur, then here we would observe, this is the reaction we would observe. Then blue color of solution, blue color due to electronic transition or paramagnetic nature we would observe. But liquid ammonia remains diamagnetic. Liquid ammonia, it shows paramagnetic nature, but not diamagnetic. Only one option, that is fourth option is does not occur, or correct answer we would observe. 22D. 23. When sodium chloride is dissolved in water, sodium ion is sodium chloride, sodium ion surrounded with water molecules we would observe, that is called hydrated form of sodium ion. So therefore, hydration capacity as moving down the group decreases, sodium is hydrated with water. So therefore, NaCl, their hydration takes place. 23D, that is every sodium ion surrounded with water molecule. As moving down the group, size increases, hydration energy or hydration enthalpy is inversely proportional to size of ion. Therefore, hydration takes place upper element Cc. 24. Which of the following imparts violet coloration to the Bunsen flame in non-luminous flame or blue flame? So then there we would observe sodium chloride gives brick red color, barium chloride gives apple green, calcium chloride, sodium chloride golden yellow color, sodium shows golden yellow, barium chloride apple green, calcium chloride brick red, potassium chloride, it shows violet or lilac flame, pink violet. The answer is exactly correct. We would observe among those. Then Epsom salt, MgSO4 7H2O is called Epsom salt. That is A. Answer A is correct. 25A. Then 26. What is X in the equation? CaO plus 3C. CaO plus 3C. That is 26. Gives calcium carbide plus carbon monoxide as a byproduct. We would get at 3000 degrees centigrade or 3273 Kelvin calcium carbide. This is X compound we would observe. Then that calcium carbide by the hydrolysis, we would get acetylene, or the supplying of nitrogen gives nitroline, calcium cyanamide plus graphite. That is allotropic modification take place, calcium carbide into graphite. That is coke converted into graphite. Then there we would observe calcium carbide is the answer for CaO plus 3C. That is B answer. Electrolysis of molten sodium chloride leads to the formation. Molten sodium chloride shows always sodium at cathode and chlorine at anode. That is the answer. If it is aqueous sodium chloride, hydrogen liberates at cathode and chlorine liberates at anode. But molten shows sodium at cathode and chlorine at anode. Therefore, 27D answer is correct. Then 28. Soda ash is also called sodium carbonate, that is Na2CO3. If it is there 10H2O, then it has been converted into, what do you say, washing soda. Washing soda, when exposed to air, it is slowly converted into soda ash. That process of conversion of washing soda into soda ash is called efflorescence. It is not needed, but that is an extra point for you. Then the hydration enthalpy of Mg plus 2 ion is larger than that of, compared to 2A group elements, hydration energy is always more than 1A group elements. Therefore, with increasing of charge, hydration energy increases, lower charge shows lesser hydration energy. Therefore, compared to magnesium, magnesium hydration enthalpy is more than sodium ion. That is B answer is correct. 30. Which of the following is used as antacid? Then milk of magnesia, MgOH twice. It is most widely using as an antacid, and therefore magnesium hydroxide, that is B answer. It is also called milk of magnesia. It is for acid HCl produced in our stomach is controlled by taking magnesium hydroxide or aluminum hydroxide. And that is B answer we would have. 31. An amphoteric oxide dissolves HCl to form salt. The salt does not impart any color to the flame and fumes in melt air. The oxide is beryllium oxide. Beryllium components show, or lithium components show, always amphoteric in nature. It reacts with sodium hydroxide, sodium berylate, and reacts with HCl, converted into beryllium chloride. Then there we would observe amphoteric nature of beryllium oxide. That is 31. C answer is correct. Then question, level 2 questions, 32, more than one answer questions. 32, please check carefully, everyone. Level 2. The alkali metals are characterized by which of the following properties? Alkali metals always show high boiling point, high negative standard electrode potential. Lithium, when we take the highest standard SRPR standard electrode potential, we would observe. Therefore, the more negative reduction potential we would observe for lithium, high negative standard electrode potential. With that, we can easily recognize with alkali metals. That is 32B and large atomic size. Another point we would observe large atomic size. Therefore, 32B and D both are correct answers. Then 33. Which of the following compounds of sodium are used for textile industry? Textile industry most widely sodium carbonate, dyeing and printing purpose, most widely using sodium carbonate, dyeing and printing purpose. Sodium carbonate most widely using, and sodium hydroxide is most widely used for mercerizing cotton fabric. Mercerizing cotton fabric, then sodium hydroxide or caustic soda most widely using. Sodium carbonate, sodium bicarbonate and sodium chloride cannot be used for textile industries. Therefore, A and C both are correct answers. 34. Identify the correct formula of halides of alkali earth metals from the following. Alkali earth metals, when we take barium chloride 2H2, as moving down the group, hydration capacity decreases. Magnesium chloride and calcium chloride, they exist with 6 moles of water, that is MgCl to 6H2O, CaCl to 6H2O. But barium chloride, when we take only 2H2O, exists with barium chloride due to large size hydration capacity decreases. Therefore, A, BaCl2, 2H2O and C, CaCl2, 6H2O, but not BaCl2, 4H2 or strontium chloride, 4H2O, wrong answers. Therefore, 34, A and C both are correct answers. 35, which of the following statements are true about beryllium and its compounds? Beryllium compounds, when we take, beryllium exhibits coordination number more than 4. Beryllium cannot show more than 4, only 4 it shows. Then beryllium sulfate is readily soluble in water as a greater hydration energy. Exactly correct, because of small size, hydration energy is more for beryllium. That is B is the correct answer. And again, we have to go with another answer. Beryllium is not readily attacked by acids due to the formation of oxide layer on the beryllium. It cannot react with acids. That is also correct answer. That is C. Oxide layer forms or oxide film forms on the beryllium metal, therefore it cannot attack with acids. Therefore B and C both are correct answers. Beryllium oxide is purely acidic in nature. Beryllium oxide is amphoteric in nature. Already we learned beryllium oxide is amphoteric in nature but not acidic. Therefore that is incorrect. Therefore B and C both are correct answers. 35. Which of the following are not the correct reasons for anomalous behavior of lithium? Or not, that is incorrect. That is correct answers we need. Incorrect with respect to lithium, anomalous behavior of lithium. Anomalous behavior, exceptionally small size of its atom. Small size is every first element shows always anomalous behavior or special characteristic. Therefore, that is the correct answer. Its low polarizing power, its highest polarizing power, pp plus polarizing power for cation is maximum in case of lithium. In next paragraph, one of the statement they provided, lithium ions possess highest polarizing power. In paragraph 39 to 43 questions in paragraph, that statement itself gave that answer. So therefore, the low polarization power is wrong, but highest polarizing power exists for lithium due to small size. Then the it has high degree of hydration. It has high degree of hydration is correct, but not incorrect. Therefore, C is the correct answer, but not a correct option. Then exceptionally low ionization enthalpy. As moving down the group, ionization enthalpy decreases. Therefore, higher ionization enthalpy, low ionization is wrong or correct answer. Therefore, B and D both are correct answers. We can take B and D both are correct answers, or they are incorrect with respect to lithium anomalous behavior. Then 37. About this elements, when we take reaction with oxygen, small size cations reacts with oxides due to oxides, peroxides and superoxides. When we take, we can identify like this. Size of oxide is smaller compared to peroxide and superoxide. So then oxides reacts with lithium, and sodium ion reacts with peroxides, and potassium, rubidium, and and cesium ions reacts with superoxides. Larger size ion easily reacts with larger size cations. Smaller size ion easily reacts with the smaller size cations. Therefore, lithium gives lithium oxides, sodium gives sodium peroxides, and remaining all these they give superoxides. This M indicates potassium, rubidium, and cesium, they form superoxides. Larger size ion, larger size cation. Smaller size cation reacts with smaller size oxide ion. Therefore, lithium oxide, when it dissolves in water, it changes to give lithium hydroxide. Sodium hydroxide reacts in water, gives hydrogen peroxide, With sodium hydroxide we would get. Hydroxide and peroxide we would get with any other peroxide compounds. Then superoxides, when it dissolves in water, hydroxide plus peroxide plus oxygen gas excess we would get. Peroxide they produce, peroxide with oxygen, then peroxide they give only hydroxides with hydrogen peroxide. So that difference you can take from these. Then when we take this potassium superoxide, that is KO2, reacts with water, the products formed are KOH, H2O2, and O2. Then these, if it is M is K, then KOH plus H2O2 plus O2 we would get. So therefore, there we would observe A, B, and D answers are correct. A, B, and D with respect to 17th question. 18th one. Sodium oxide cannot be prepared by. Sodium cannot react with other sodium compounds, but sodium peroxide reacts with carbon monoxide and then converts into sodium oxide plus carbon dioxide. We would get sodium cannot react with sodium nitrate or sodium nitrite or sodium peroxide. So therefore, B, C, and D are the correct options because sodium oxide cannot react with sodium oxide cannot be prepared by those three methods. Sodium oxide plus carbon dioxide we would get only. First method is eligible for the preparation of sodium oxide and carbon dioxide. Then paragraph they provided with respect to anomalous behavior of lithium and lithium properties. Then if you refer, please refer that paragraph, everyone please. Then if you refer, we would come back to question number 39. 39th question we would observe, which of the following undergoes hydrolysis by cold and hot water? Hydrolysis easily lithium chloride, sodium chloride, rubidium chloride undergo hydrolysis by cold and hot water. Only potassium chloride it undergo with hot and cold water, but lithium chloride hydrolysis that we would observe. Hydrolysis means cation hydrolysis take place. Sodium chloride cannot undergo hydrolysis due to small. That is hydrolysis. We know that weak cations and weak anions they cannot react with water, but strong cations and strong anions they react with water. Undergo hydrolysis by cold and hot water, only potassium chloride, but not other cations or anions. Then 40. The small size of lithium ion cannot explain. Small size of lithium ion cannot explain means only high dipole moment of lithium iodide. High dipole moment of lithium iodide, dipole moment according to Fazan's rule, small size cation and large size anions always they are more covalent character. Large size cation and small size anion always give more ionic character. So therefore, polarizing ability they are showing, but high dipole moment of lithium iodide, small size of lithium ion cannot explain why lithium iodide cannot exist. Then that is 40 C answer. 41. The correct sequence of increasing covalent character is represented by covalent character represented by sodium chloride less than lithium chloride less than beryllium chloride. Increasing covalent character across the period, covalent character increases as moving down the group, ionic character increases. Therefore, sodium chloride is more ionic or least covalent than lithium chloride than beryllium chloride. That is 41B answer we can take. 42. Which ion has the maximum polarizing power? Which ion has the minimum polarizing power? Polarizing power of with increasing of size of ion, polarizing power gradually decreases. So compared to lithium, sodium, and magnesium, largest size is there for potassium ion. Therefore, potassium has minimum polarizing power. 42 C answer. Matrix match type. Flame coloration. Flame coloration here we would observe option they give in your answer sheet only yes. Flame coloration given by potassium ion Kf, Q and S. A for QS, potassium gives lilac or pink violet color. Then lithium shows crimson red color. Therefore, both they give Q and S answers we would observe for 43A QS. Please make Q extra in your answer lists. Then saturated stored under kerosene. So which metal we can easily store under kerosene? Alkali metals, that is sodium most widely stored under kerosene. That is B answer. Then C, soluble in organic solvents. Organic solvents soluble, we would observe beryllium as well as lithium salts, they give covalent character, they soluble in organic solvents. Therefore C, R and S, both are answers. D, soluble in water without any reaction with it. Then only without any reaction, soluble in water without any reaction with it. Due, that is potassium fluoride, soluble without any reaction. Metals they react, but salts cannot react. Then 44, when we come across, match the compound with their properties. Calcium carbonate properties are there R and S. That is R shows insoluble in water but dissolves in the presence of carbon dioxide. Calcium carbonate plus water plus CO2 gives calcium bicarbonate. Bicarbonates are soluble in water, they create degree of hardness. Calcium sulfate 2H2O, CSO4 2H2O they give. Then also we would observe gives precipitate with sulfuric acid. Carbonate or sulfate salt, they always insoluble salts or sulfates are produced. Therefore, RS are answers for A. B, calcium sulfate 2H2O, insoluble in water. All sulfate salt, alkaline earth metal sulfates are insoluble in water due to their ionic product exceeds solubility product. Then barium carbonate again R and S, both the reasons we would observe insoluble in water but dissolves in the presence of carbon dioxide because of barium bicarbonate produced CO2 plus H2O when we mix, and gives precipitate with dilute sulfuric acid because of barium sulfate forms it is insoluble in water. Beryllium hydroxide, only amphoteric nature. Lithium and beryllium salts, they give amphoteric nature. Therefore, beryllium hydroxide shows amphoteric nature. That is D, Q answer. Then integer type, 45. The number of compounds among the following that do not produce acidic or basic solutions when dissolved in water. Then there we can observe amphoteric nature reacts with acids and bases are beryllium chloride, lithium, beryllium chloride, barium chloride and calcium sulfate. Barium chloride because of weak cation and weak anion cannot undergo hydrolysis. Calcium and sulfate ions also weak cation and weak anion. Therefore, there we would take sodium chloride, barium chloride and calcium chloride cannot undergo hydrolysis, or else they show what nature we would observe, do not produce acidic or basic nature, amphoteric nature provided by sodium chloride, barium chloride and calcium sulfate. Therefore, 3 is the answer. But extra information you want to write, please write down. Beryllium chloride show acidic nature, lithium oxide, magnesium oxide and calcium hydride show basic nature. Then 46. The number of elements among the following that do not give characteristic color in flame test. Cannot give characteristic color, beryllium and magnesium salts. Therefore, 2 is the answer, and remaining calcium shows brick red, lithium shows crimson red, barium apple green, strontium red, sodium shows golden yellow, potassium shows pink violet or lilac flame. Only beryllium and magnesium cannot give any characteristic color. 47. The ratio of number of water of crystallizations in gypsum and plaster of series. Gypsum 2H2O, plaster of Paris half H2O exists. Hemi CaSO4 half H2O we would observe, or else 4:1. 4:1 it indicates with the ratio we would observe 4. Therefore, integer value of 47 is 4. Then 48, last question in S block elements. The number of elements among the following that will form nitrides when heated in the atmosphere of nitrogen. Nitrogen, lithium reacts with nitrogen to give lithium nitride, calcium nitride, barium nitride, strontium nitride, magnesium nitride. In 2A group elements, except beryllium, remaining all elements they react with nitrogen and they converted into their nitrides. But alkali metals, when we take, only lithium gives lithium nitride. Other elements they cannot give direct combination with the nitride formation. Therefore, there we would have the lithium, calcium, barium, strontium and magnesium. 5 is the correct answer among those. So that's all that is about S block elements. Thank you for everyone.